Hey there. Ever wonder how a coach or an AI could tell if you're nailing a yoga pose or mastering a guitar riff? It's not just about watching a video, it's about how you analyze it. Today, we're breaking down two revolutionary methods, PATS and Skillformer, that are changing how we measure human skill through motion. Let's dive in. Here's the problem. Traditional video analysis is like trying to understand a symphony by only listening to random notes. You might catch a few sounds, but you miss the rhythm, the flow, the essence of the performance. That's where PATS comes in. Short for Proficiency-Aware Temporal Sampling, this method doesn't just grab random frames from a video. It identifies complete movement patterns, like the full arc of a basketball shot or the fluid motion of a dancer, and ensures those moments are studied in their natural flow. Think of it as taking photos of a dance move as it happens, not just random stills. But how does it work? Instead of sampling frames at regular intervals, PATS divides a video into continuous time segments, like chapters in a book. Each chapter captures the full execution of a skill. For example, in a bouldering climb, it'd focus on the entire sequence of a difficult move, not just a single grip or foot placement. This way, the AI sees the whole story of the skill, not just pieces of it. And here's the key: PATS adapts. It dynamically adjusts to the speed and complexity of the action. Whether it's a soccer pass executed in a fraction of a second or a gymnast's slow, deliberate routine, PATS prioritizes the moments that define proficiency. It's like a camera that automatically zooms in on the critical details, whether you're filming a sprint or a symphony. Now let's talk results. When tested on a massive dataset of sports videos, PATS outperformed existing methods by up to 3%, a significant leap in accuracy. In rock climbing, it boosted performance by 26%. This isn't just a tweak. It's a game changer for coaches, athletes, and AI systems learning to evaluate skills in real-world settings. But PATS isn't the only star here. Enter Skillformer, a model that doesn't just watch videos, it analyzes them from every angle to measure proficiency. Traditional systems often rely on a single perspective, like a fixed camera or a first-person view. But real-life skills, like dancing or sports, involve complex movements that change depending on the angle. Skillformer solves this by using multi-view analysis, combining information from different camera perspectives to get a fuller picture. Imagine recording a backflip. A single camera might miss critical details, like hand placement or body alignment. But if you also have a side view, an overhead shot, and a close-up, Skillformer cross-references all these angles. It uses transformer-based architecture to synchronize and interpret data from multiple viewpoints, effectively creating a 3D representation of the movement. This allows it to detect subtle flaws, like a slight tilt in a gymnast's landing or an off-kilter posture in a martial arts form, that a single camera might overlook. Together, PATS and Skillformer represent a leap forward in motion analysis. PATS ensures we capture the what of a skill, while Skillformer deciphers the how. These tools aren't just for athletes, they're reshaping how we train, teach, and even entertain. Whether it's refining a dancer's technique or teaching an AI to recognize a perfect tennis serve, these methods are redefining the boundaries of human-machine collaboration. So next time you watch a video, think, what's being seen and what's being missed? The future of motion analysis isn't just about recording movement. It's about understanding it. Thanks for watching, stay curious, and keep exploring the intersection of skill and technology.